A password field accepts between 8 and 20 characters. Most testers open the form, type a 10-character password, it works, and they move on. But where are the bugs actually hiding? They are hiding at 7 characters, one below the minimum. They are hiding at 8, exactly the minimum. They are hiding at 20, exactly the maximum. And they are hiding at 21, one above the maximum. Not at 10. Not at 15. The bugs live at the edges. And the reason is one of the most common mistakes developers make, the off by 1 error. The condition that says greater than 8 instead of greater than or equal to 8. The loop that runs one time too many. The validation that lets in one too few. Boundary value analysis is the testing technique built specifically to hunt those bugs. And once you learn it, you will find more defects per test case than with almost any other approach. Boundary value analysis, or BVA, is a test design technique based on a simple insight: most logic errors happen at the edges of valid input ranges, not in the middle. If a field accepts values from 1 to 100, the developer wrote code that checks whether a number is in that range. And the most common place that code is wrong is right at the boundaries, at 0, at 1, at 99, at 100, at 101. Boundary value analysis gives you a systematic way to identify exactly which values to test. For any input with a defined range, you test 6 values, minimum -1, just outside the valid range on the low end. Minimum, the first valid value. Minimum +1, just inside the valid range. Maximum -1, just inside on the high end. Maximum, the last valid value. Maximum +1, just outside on the high end. That is 6 test cases per boundary. And those 6 cases will consistently expose off by 1 errors, missing validation, and fence post bugs that random testing misses entirely. Let's apply this to a real example. You are testing an age verification field on a website. The requirement says users must be between 18 and 65 years old to register. That gives you 2 boundaries, a minimum of 18 and a maximum of 65. Apply the BVA formula. For the lower boundary, your 6 test cases are 17, below the minimum, should be rejected. 18, exactly the minimum, should be accepted. 19, just above the minimum, should be accepted. For the upper boundary, 64, just below the maximum, should be accepted. 65, exactly the maximum, should be accepted. 66, above the maximum, should be rejected. Now here is how you build the test matrix. You write a table with 3 columns: input value, expected result, and actual result. 17, expect reject. 18, expect accept. 19, expect accept. 64, expect accept. 65, expect accept. 66, expect reject. 6 rows. 6 test cases. And those 6 cases will catch the most common implementation errors on this field: the developer who wrote greater than 18 instead of greater than or equal to 18, the developer who forgot to cap at 65, or the one who validated 66 as in range by accident. That is BVA in practice. Systematic. Minimal. Highly effective. Now let's add a second tool to your kit: equivalence partitioning. Boundary value analysis tells you which specific values to test at the edges. Equivalence partitioning tells you how to group the rest. The idea is that all values within a valid range produce the same behavior, so testing one value from each group is enough. You do not need to test every number between 19 and 64. Any one of them will behave the same way. So you test the boundaries plus one value from the middle of the valid range, and you are done. Combined, these two techniques give you a minimum test set that covers maximum risk. Let me show you with the password field example. The requirement: passwords must be 8 to 20 characters. BVA gives you 7 characters, reject. 8, accept. 9, accept. 19, accept. 20, accept. 21 reject. Equivalence partitioning says, test one valid value in the middle, say 12 characters. That is 7 test cases total for a field with an infinite number of possible inputs. Now think about how many fields a typical registration form has: username, password, email, phone, address, zip code. Each one has boundaries. Apply this to all of them, and you have a compact, high-impact test suite that finds the bugs worth finding. Here is why boundary value analysis is one of the highest ROI testing techniques you will ever learn. Off-by-one errors are consistently among the most common bug types in software. Studies have placed them at 10 to 15% of all defects. And they are almost never caught by exploratory testing, because exploratory testers naturally gravitate toward typical, comfortable values. Nobody types in their age as 65 or 66 unless they are specifically trying to test a boundary. Developers also naturally test with values in the middle of the range when they verify their own work. So boundary cases go untested by both the developer and the QA engineer unless you have a systematic technique that forces you to look there. BVA is that technique. It is not about being clever. It is about being systematic. Every time you see a requirement that contains the words minimum, maximum, at least, no more than, between, or from to, that is a signal. There are boundaries there. Apply BVA. Write 6 test cases per boundary. And you will consistently find defects that every other approach misses. Let's recap. 1. Most logic bugs live at the edges of input ranges, not in the middle. 2. Boundary value analysis tests 6 values per boundary: min -1, min, min +1, max -1, max, max +1. 3. Off-by-one errors are among the most common defect types. BVA is designed to catch them. 4. Equivalence partitioning complements BVA. Test one value per valid partition plus the 6 boundaries. 5. Watch for keywords and requirements: minimum, maximum, between, at least, no more than those signal boundaries to test. 6. BVA is systematic, not clever. It forces you to look exactly where developers and testers naturally skip. In the next video, we are tackling the QA interview question that trips up 90% of candidates, even experienced ones. If you have ever been asked about your testing process and felt like you gave a weak answer, this one is for you. Subscribe so you don't miss it. Drop a comment. What input field on a real app you use would you apply BVA to right now? QA Career Lab. Because quality is not an accident. It is a practice.